Good afternoon, children. How are you today? It is I, Mr. E, and we are going to do the last bit of this factoring notes. We're going to do some special products, but first, get rid of this. Let's do just a regular one here to review. Let's do this one over here because this one has a. Well, you know what? I'm going to do both of these real quick. I'm going to show you some shortcuts for this one right here. First, we're going to fill in the values here. A is 1, B is a positive 7, and C is a negative 18. So A times C, that's a negative 18. B is a 7. Positive 7 goes down there. So we need to find two factors of negative 18 that add together to be 7. And hopefully by now you've learned the calculator trick to do that, or maybe you make a table like this. 1 times 18 is 18. 2 times 9. Oh, I'm sorry, that's negative. So negative 2 times 9. Well, look at here. That difference is 7, but it needs to be a positive. So let's put the negative on the 2, a positive 9. So there's our two factors. Minus 2 times 9 is negative 18, and minus 2 plus 9 is a positive second. So we'll use those factors. So x squared goes here. We'll put a minus 2x here, a positive 9x there, and then a positive, I'm sorry, the last box, negative 18 goes there. So here's a quick trick. If you have no a value, not no a value, if your a value is 1, then filling this stuff out is easy because your teacher probably might have already told you. If you just have an x squared there, then you've got an x and an x on either side. And again, if your a value is just 1, then just all you got to do is put these numbers right here and that number right there. That's it. So now x squared plus 7x minus 18, the factored form is just x minus 2, x plus 9. So there you go. When your leading coefficient, when that a value is 1, filling these out are real easy. It's just those numbers. So let's do one that's slightly more involved, and that is over here. So let's see. Our a value is 4 now, and our b value is minus 12, and our c value is a positive 9. So a times c, that is 36, positive 36. B value is minus 12. So now we need two numbers that multiply together to get 36, but add together to get minus 12. Some of you may have seen this already. We've got 6 and 6. 6 times 6 is 36. 6, but we need to add these together to get minus 12. So we're going to make them both negative. So a negative times a negative is a positive. That works. Negative plus a negative 6 is a negative 12. So now we'll just write our pieces in here. We've got a negative 6x here and a negative 6x there, and then plus 9. So now we need to go back, and now we know that an x goes here and an x goes there. An x and will always go there, whether or not you have a is 1 or not. But now we need to find the GCF of each row and column. So let's find the GCF of this row. What number is common to both of those? What factor is common to both of those? I'm going to say it's 2. Get rid of these. So, yeah, 2. What happened? Okay, so 2. 2 times, and now I need to ask myself this question. What times 2x gives me 4x squared? And that is 2. 2 times 2 is 4. X times x is x squared. Now, what times 2 gives me a minus 6? That'll be a minus 3. 2x times minus 3 gives me minus 6x. And it's the same thing down here. It's the same numbers. And then we can check. Minus 3 times minus 3 gives me a positive 9. So there we go. That's our factors. It's 2. That's not even what I wanted to write. 2x minus 3. Both of them are 2x minus 3. So we can write the answer like that. 2x minus 3 squared. So there's our factored form for 4x squared minus 12x plus 9. Okay, so there's a quick review on how to factor that. But now we're going to talk about some special products. So a perfect square trinomial, it's where the factored form is the square of a binomial. So one of these, just like what we saw up here, this right there. When both factors are the same, then you've got what we call a perfect square trinomial. So, and they all have this same form. So really, we don't need to do a whole lot of work. We just move the numbers around. So let's put this where I can write better. Okay, so let's see. Let's just find our A, B, and C values. A here is 1, B here is 12, and C here is 36. So the answer is just in this form. If I've got, let's see, this is a negative, and it doesn't it? So this is positive. That's not even. This is positive, and this is positive. That's a negative, but over here we've got a positive and a positive. So let's do this. We are going to factor this, and oh yeah, all we need to do is really just find the square roots of the first term and the second term. So the square root of x squared, well, that's just x. And then the square root of 36, you can pop that in your calculator if you want, but that's 6. So here's the answer. X plus 6 squared. That's it. That's all there is. So let's try another one. Let's see, we got 9x squared plus 12x plus 4. So we really don't need to write out the a, b, and c values. Let's find the square root of the first bit and then the square root of the second bit. So the square root of 9 is 3. The square root of x squared is x. So the first term is 3x. And the square root of 4, that's 2. So here's our answer. Right there. There's the first answer. Let's do this last one, just so we know what we're doing. Oh, this one has a negative sign here, so we're going to use this form over here, and it's going to look like this, a minus b. So let's find the square root of 4x squared. The square root of 4 is 2, and the square root of x is x, as we've shown here before. And then the square root of 9, well, that's just 3. So here's our factored form, 2x minus 3 squared. There we go. Those are pretty easy. So if you recognize this form, recognize that form. See, it's a perfect square trinomial. Or rather, if you see that these here are perfect squares, perfect squares, perfect squares, perfect squares, perfect squares, then you can factor that really quickly by just moving those letters around, finding those square roots and doing that. If you don't recognize it, that's okay. Just use the box method or whatever your teacher has showed you. Split the middle, whatever you like. So here's the last one. The difference of two squares is a special one that we've seen before. It was on the packet. There was one there where you had x squared minus 81. Now, these are the form, if you see that this is a perfect square, or if you see that both are perfect squares, which it is in this case, then all you need to do is find the square root of both of those again. So the square root of x squared equals x. The square root of 49 equals 7. And that's a negative 49. But it doesn't matter because, well, you can't find the square root of a negative number. Not yet, anyway. So we just need to find the square root of that, 7. So that takes this form right here. You're going to have x minus 7 and x plus 7. So there's another pattern you can try to recognize if you like. Here's one. We're going to take the square root of this, the square root of 9p squared. Well, the square root of 9 is 3, and the square root of p squared is just p. There's that. And then the square root of 16 is 4. So these are the two pieces that we need. So I've got 3p minus 4 and 3p plus And that is it for the rest of the end of these notes. Those are some special products there, some special things that you can recognize. And I'm just going to leave it there. This will be real quick because even if you don't recognize these, you can still use the box method. For these down here, the difference of two squares, if you only have these two, how many middle terms do you have? It usually has an x in it, right? We have an x squared, but no x, there's no middle term. So use 0. Just use 0 in your grid. Put the 0 down there for b, and then factor away. So there's that, and I will see you on the next video. Bye.